Hi, welcome back to maths class. Second bit, fourth bit lo first one. If z1 comma z2 are two non-zero complex numbers satisfying modulus of z1 plus z2 is equals to modulus of z1 plus modulus of z2, then show that arg z1 minus arg z2 is equals to 0. We have to show arg z1 minus arg z2 is equals to 0. Solution: z1 is equals to x1 plus I y1 and z2 is equals to x2 plus I y2. Given modulus of z1 plus z2 is equals to modulus of z1 plus modulus of z2. So z1 z2 substitute in this term, that is modulus of z1 is x1 plus I y1, z2 is x2 plus I y2 equals to modulus of z1 is x1 plus I y1 plus z2 is x2 plus I y2, modulus of x2 plus I y2. So in this term, we can write real parts are one side, x1 x2 are real parts, x1 plus x2 plus y of imaginary part is y1 I y1 I y2, I of y1 plus y2 equals to modulus of x1 plus I y1 plus modulus of x2 plus I y2. So this is again x plus I into y, x plus iy. So modulus of x plus iy formula is under root of x square plus y square. So under root of x square, x means x1 plus x2, x1 plus x2 whole square, y square means y1 plus y2, y1 plus y2 whole square equals to, here also same, modulus of x1 plus iy1 is under root of x1 square plus y1 square plus under root of x2 square plus y2 square. Now we can do squaring on both sides. Squaring on both sides. Under root of x1 plus x2 whole square plus y1 plus y2 whole square equals to root of x1 square plus y1 square plus root of x2 square plus y2 square whole square. Root square get cancel. This is again in a plus b whole square form. So here x1 plus x2 whole square, a plus b whole square formula, a square plus b square plus 2ab. A is x1, b is x2. So we can apply a plus b whole square formula here, that is x1 square plus x2 square plus 2ab. 2ab means 2x1 x2. Here also same, a plus b whole square formula, y1 square plus y2 square plus 2y1 y2 equals to, this is again, this is a, this is b, a plus b whole square. So here we can apply a plus b whole square formula. A square means root x1 square plus y1 square whole square, b square means root x2 square plus y2 square whole square plus 2ab plus 2ab. 2 into root of x1 square plus y1 square, this is a, this is b, x2 square plus y2 square. Here root square get cancelled, root square cancel. x1 square plus x2 square plus 2 into x1 x2 plus y1 square plus y2 square plus 2 into y1 y2 equals to, here x1 square plus y1 square plus x2 square plus y2 square plus 2 into root of, here 2 into root of x1 square plus y1 square into root of x2 square plus y2 square. Here x1 square get cancel, x2 square get cancel, y1 square cancel, y2 square cancel. Remaining terms is, in this I am taking 2 is common, 2x1 x2, 2y1 y2, 2 of x1 x2 plus y1 y2, that equals to 2 into root of x1 square plus y1 square, root of x2 square plus y2 square. 2 get cancelled. So now again we can do squaring on both sides. Squaring on both sides. Here x1 x2 plus y1 y2 whole square equals to x1 square plus y1 square whole square. Here multiplication, x2 square plus y2 square whole square. I am directly applying square to both terms. So root square get cancel, root square cancel. This is again in a plus b whole square formula. This is again a plus b whole square. So a square plus b square plus 2ab, x1 square x2 square plus y1 square y2 square plus 2ab means 2x1 x2 y1 y2 equals to x1 square plus y1 square into x2 square plus y2 square. Here x1 square x2 square plus y1 square plus y2 square plus 2x1 x1 x2 y1 y2 equals to, multiply these two terms, x1 square into x2 square, x1 square x2 square plus x1 square into y2 square, x1 square y2 square plus y1 square into x2 square plus y1 square y2 square. In these two terms, x1 square x2 square, x1 square x2 square get cancelled, y1 square y2 square get cancelled. Here remaining term is 2x1 x2 y1 y2 equals to x1 square y1 y2 square plus y1 square x2 square. So from this I am writing like this, x1 square y2 square plus x2 square y1 square minus, I am taking this term to this side, that is minus 2x1 x2 y1 y2 is equals to 0. So I am writing this term like x1 y2 whole square plus x2 y1 whole square minus 2 into x1, here x1 y2, here x1 y2. We are writing like a square plus b square minus 2ab form. 2 a means here x1 y2, b means x2 y1. So here 2ab, ab means a is x1 y2, b is x2 y1. So now we can write a minus b form, x1 y2 minus x2 y1 whole square, that equals to 0. Here equals to 0. So x1 y2 minus x2 y1 is equals to 0. Here x1 y2 equals to x2 y1. From this y2 x2 equals to y1 x1. So taking tan inverse on both sides, taking tan inverse on both sides, tan inverse of y2 by x2 equals to tan inverse of y1 x1. So tan inverse of y2 x2 means arg z2. Arg z is nothing but theta. Theta is tan inverse of y by x. So arg z2 equals to, this is arg z1. Arg z1. Here arg z1, I am taking this term to this side, that is minus arg z2 is equals to 0. This is a solution for first one. So see the next problem. Second problem, if z1 is equals to x plus iy and the point P represents z in the organed plane and modulus of z minus a by z plus a bar is equals to 1, real part of a not equals to 0, then find the locus of z. Locus of z means equation of z. Solution, given z is equals to x plus iy, in this I am taking let a is equals to alpha plus I beta, a bar is equals to alpha minus I beta. This is conjugate of this one. Here given real part of a not equals to 0 means in this real part is alpha, imaginary part is beta. So real part not equals to 0. So alpha not equals to 0. Given modulus of z minus a by z plus a bar is equals to 1. So I am writing modulus of z minus a equals to modulus of z plus a bar. Modulus of z means x plus iy, x plus iy minus a means alpha plus I beta, minus of alpha plus I beta, that equals to modulus of z is x plus iy plus a bar is alpha minus I beta. So alpha minus I beta. So in this I am writing real parts are one side. Modulus of x minus alpha. This is real part. Imaginary part I of y minus beta. Same. In this also we can write real parts are one side. X plus alpha is a real part. I of y minus beta. This is the imaginary part. So now apply the modulus formula. Modulus of this is x plus I y form. So under root of x square plus y square. Under root of x means x minus alpha whole square plus y minus beta whole square. Same. Here also apply the modulus formula. X plus alpha whole square plus y minus beta whole square. Now squaring on both sides. X minus alpha whole square plus y minus beta whole square equals to root of whole square. So root of x plus alpha whole square plus y minus beta whole square. Here again whole square. Square root cancel. Square root get cancel. So remaining term is x minus alpha whole square plus y minus beta whole square is equals to x plus alpha whole square plus y minus beta whole square. Here y minus beta whole square get cancelled. Remaining term is x minus alpha whole square x plus alpha whole square. Apply the a minus b formula. X square plus alpha square minus 2x alpha equals to same a plus b whole square form. X square plus alpha square plus 2x alpha. Here x square alpha square get cancelled. So 2x alpha, I am writing this term to this side, that is plus 2x alpha is equals to 0. Then 4x alpha is equals to 0. Here I am taking 4 to the right hand side, that is 0 into 4 0. X alpha is equals to 0. But given that real part of a not equals to 0. Real part of a means alpha not equals to 0. Therefore x is equals to alpha not equals to 0, then x is equals to 0. Therefore the locus of z is x is equals to 0, implies it is y axis. X is equals to 0 means it is y axis. Second problem is completed. So if you have any doubt, please comment, like, share, subscribe for more videos.